Hello everyone, myself Barnana Bhattacharya. I am the economics faculty, economics lecturer in Narayana group. I am working with Narayana Junior College now, and today I am going to explain a very renowned topic of managerial economics, that is prisoner's dilemma of game theory. And I will be showing a PPT. I will be presenting a PPT on that particular topic and will explain it, okay, thoroughly. So for doing that, I have to share my slides. So I'm just sharing screen. I think is it visible? I think is it visible to all of you? And see, today's topic is prisoner's dilemma, but it is a part of game theory. Game theory is a very, very important and renowned topic of managerial economics. So here, before going to the main focus of the topic, we are going to learn about game theory. Okay. So in case of game theory, firstly, we need to know what is game theory. See, game theory is a theoretical framework based on some mathematical models, which models deals with the decision makings of the individuals. Okay, if that means if there is some conflicts of choices, then game theory is the solution to make a choice. Okay, so firstly we need to know the basics of game theory. Okay, so firstly we're having what is game. So if I'm going to understand the game theory, we need to know what is game. See, here interaction among two or more players where payoff of each and every player will be affected by the decisions taken by them and taken by other players. So let me explain in a very easy way. Game is the interaction between two players. Players means what? I am going to explain in the next part. So there are interaction between two individuals who are going to choose a strategy, who are maybe one will be affected by another one's decision and vice versa. Okay, next thing is players. So if I'm talking about the interaction between players, we need to know what these players, who these players are, right? So players, the independent actors of the game. Okay, now let me tell you, there are some interdependent individuals who are actually dependent on each other, and they are facing the game. They are facing some choices, some strategies for making decisions, and those those particular individuals are choosing the strategies. So that means in the game, who are taking the decisions by choosing some strategy, decision making strategy, are called players. Next, strategy. If I'm talking about strategy, strategic decisions, then we need to what is strategy? So strategy, the complete plan of actions that a player will take in a conceiving social circumstances. In other words, in very easy words, the choice guideline by which a player fixes his game plan is called strategy. That means when two or more individuals are said to choose between some actions, choose between some options, then when they set up their plan, their guideline of choosing one option, making decision, then that particular plan of action is called strategy. Okay, so I'm moving forward to the next slide. Hope it is very much easy to all of you. Okay, so as we know about the strategy, the game and the players, now if you find the types of strategy, you will be finding three types of strategies over there in game theory. One is pure strategy, another one is mixed strategy, and third one is optimum strategy. Now let me tell you what is pure, what is mixed, and what is optimum. So see, in case of pure strategy, in case of pure strategy, what is happening? The main objective of the player is to maximize their gains or minimize their losses. So in under pure strategy, the main objective of the player should be to maximize gain or minimize loss. That's it. In the mixed strategy, what is happening? Here, what individuals or players are doing? They are, while making decision, what they are doing, they are mixing some of choices in some fixed proportion and taking the decision. What they're doing, then mixing maybe two or more choices and mixing it and taking action in some fixed proportion. So in that case, we can say this is a mixed strategy taken by the players. Now, optimum strategy. What is optimum strategy? Optimum strategy means it is the strategy where player augments his gains or losses without having any information about the strategies of his competitors. That means, very easily I am explaining, in case of optimum strategy, the player who is taking action, that means who is choosing between the strategies or options or choices, that particular person is unknown to the, is very much unaware about the strategies of the competitors. That means if there are two players, one is having no idea about the strategy taken by the another one and vice versa. Okay, so this is the optimum strategy can be taken by the player. Okay, now the next thing, we know the game. What is the game? Who are the players and what are the strategies? Now, payoff. Actually, in very easy way, I can say you, payoff is the outcome of the strategy. Okay, when players are choosing between the options, or taking strategies, acting to make the decision, in that case, the outcomes we are getting, the players are getting, is payoff. Let me explain it in the slides. The payout a player obtains from arriving at a particular time. That means, in a very easy way, I can say payoff is an additional gain or loss that ensue the player by implementing its strategy, keeping the other player's strategy unchanged. So, while implementing the strategy, the additional gain or loss, faced by the player is the payoff. Okay, that additional gain and loss is the payoff. And one assumption is there, while implementing the strategy, the particular player should keep other player strategy unchanged. That means constant. That means fixed. So while implementing his strategy, he has to keep it in mind that the other player strategy is fixed. Next, payoff matrix. See, payoff, we know about matrix, right? In mathematics, we have idea what is matrix. So here, payoff matrix is a table where strategies of one player are recorded in rows and strategies of the another player is in columns. That means there will be rows and columns as it is in the normal matrix. So we will be having the payoffs of both of the players. And while moving, the row player comes first. So we have to start with the row players. So now we are having idea about game, strategies, players, payoff matrix, etc. Now, if I am giving you an example, see, this is a very interesting example of game theory. Okay, here what I'm showing. Here I'm showing the payoff matrix of Starbucks coffee and San Francisco coffee, that is SF coffee. Okay, so the players are here There are two players, and who are the players? One is Starbucks coffee shop, and another one is SF coffee shop. Moves of actions what they can take. The coffee shops can either do advertisement or maybe not doing advertisement. That means either they promote their brands or they are not promoting their brands. These are the moves or actions. Okay. And payoff. What can be the payoff? See, the payoffs are the profits of firms will earn. That means the profits earned by Starbucks and SF Coffee is the payoff over here. And here we can see advertisement can increase the firm's cost and as well as revenues. So the profit will be earned more if they do advertisement. This is a very logical and very normal thing. So if you go to the Payoff Matrix, you can see we are giving a circle on the $12, which is advertisement. Okay, that means SF Coffee is also doing advertisement. Starbucks Coffee is also doing advertisement. Now, why we are doing this? See, if we choose $15 earning by Starbucks and SF Coffee, in that particular cell, we can see both of them are not doing advertisement. They are not promoting their products. So if they are not promoting their products, in that case, Starbucks Coffee can think like, if I do advertisement, I can earn more. I can capture some, percent of the SF Coffee's market. I can capture the market extra. So maybe Starbucks can move towards the next one, where Starbucks is giving advertisement and SF Coffee is not giving advertisements. In that case, Starbucks is earning $20 and SF Coffee is earning $10. Similarly, if from the beginning, if we start again and the role they are playing is exactly opposite, that means suppose SF Coffee is thinking about the advertisement. Suppose SF Coffee is thinking, if I do advertisement, I can get more dollar. I can get $20 instead of $15. So I can earn more. So maybe in that case, Starbucks Coffee will have a loss. He will be having a $5 unit of loss. But if both of them do advertise, what is happening? Maybe if they don't do advertise, the earning was better, because $15 is always better than $12. But still that $15 sale strategy is unstable, because in that particular strategy, Starbucks or SF Coffee can move. Maybe they will be dreaming about the extra earning and doing advertisement. They can change their strategies. But in case of $12, they are not changing their strategies, because in that case, both are giving their advertisements and they are having a good enough profit. Okay, see the last line. The outcome circled is known as the Nash Equilibrium, or the outcome at which neither firm has anything to gain by changing it, only its own strategy unilaterally. That means from that particular position, when both are giving the advertisements, they are stick to the strategy, because they will not move from it. Why? If they move, they can lose some amount of earning. Okay, they will be earning less profit if they are moving. So this is a very clear example of game theory. So now I think it is clear that how it works and what is Nash equilibrium is, though I will be explaining it later also while doing the prisoner's dilemma. So Nextly, I'm doing the next slide, that is C. Now we know about game theory, how it works, the payoff matrix and all those things. Next thing is maxi-min and minimax principle. In case of PO strategy, now we are having maxi-min or minimax principle. So what is it? Briefly, I'm telling you. Maxi-min principle is players' minimum gains and minimax principle is the players' maximum gains. Got it? Now the very important thing is coming, that is saddle point. What is saddle point? See, saddle point is basically the equilibrium. Okay, and this is actually the, when maximin value is exactly equal to the minimax value in the game. Okay, in the game, when maximin value is exactly equal to the minimax value, we can say the game is having an equilibrium, a saddle point. Okay, so this corresponding strategies to this point are termed optimal strategies. Okay, because we are having, if the game is having a saddle point, if the game is having a equilibrium point, then we can say it is optimal strategy. Now what is value of game? See, value of game is the expected payoff at the end. That means when each and every player uses his optimal strategy, we can reach value of game. We can have the value of game. So now there are two things you have to keep it in mind. That is, a game is said to be impartial game when maximin and minimax values of game are equal to each other and both are equal to 0. So that means when maximin value is exactly equal to minimax and both are equal to 0, we can say this is the impartial game. And this, and it can be a severely determined game when maximin value, minimax value is same and exactly equal to the value of game. So when the maximin value and minimax value are same as well as they are exactly equal to the value of game, we can say it is a severely determined game. Now see, this is the game with pure strategy. We are having two players over here. Number one player is player A, number two player is player B, and we are having 6 strategies, 3 strategies of player A, A1, A2, A3, and 3 strategies of player B, B1, B2, B3. The strategies of player A we are showing in the rows, and the strategies of player B we are showing in the columns. So what we are doing over here, we are just calculating the row minimum from the rows and column maximums from the columns. See, we are having from the first row, the minimum is out of 25, 20 and 35, the 20 is the minimum. Similarly for A2 row, 45 is the minimum. And similarly from A3, 40 is the minimum. Now, the row minimums are 20, 45, 40. So from that, we can have our maximin value. That means maximum of the minimums. Okay, so here minimum values are 20, 45 and 40, and maximum of these minimum values are 45. So 45 is the row maximin value which is calculated from the row minimums. Clear? Now if we talk about the columns, we are having for B1 58, which is the maximum value of the columns, like 25, 50 and 58. Which one is greater? 58. Similarly for the B2, 20, 45, 40. Which one is greater? 45. And similarly, the lastly B3, we are getting 55 as the minimum. So we have done with column maximums. Now from these column maximums, we are going to have the minimax value. That means minimum value of the column maximums. So which one is the minimum among this 58, 45 and 55? Obviously 45. Now see, maximin value is also 45, minimax value is also 45. So maximin equals to minimax equals to 45, and it is The game is having a saddle point. So value of the game is 45. So it can be said this is a severely determined game. So I think this is clear how to calculate minimax value and maximum value from the row minimums and column maximums of the two players. Okay, I'm moving forward. The next one, see. Now we are having two types of game with saddle points. One is without saddle point and another one is with multiple saddle points. That means in the first case, there will be no saddle point with us, and in the second case, we will be having more than one saddle points. So if we go to the first one, we are having again player 1 and player 2. Sorry, player A and player B. So if you see if you see very attentively, there are row minimums from A1 and A2, 2 and 3. Which one is the minimum? 2. Okay. If we do from the, if you calculate the column max, 5 and 4, and see here maximum value is not equals to minimax value. Okay, here maximum value is not equal to the minimax value. Okay, let me tell you, there is a there is a wrong thing in the diagram. The circle is around 2, it should be around 3, because we are calculating row minimums. Row minimums means from A1 in between 5 and 2, 2 is minimum, and from A2 in between 3 and 4, 3 is the minimum. Okay, so 2 and 3 is the minimum, but we are calculating the maximum of row minimums. So which one is maximum from 2 and 3? 3. So the circle should be around 3. There is a mistake. And from the column maximum, what we are doing? We are calculating from B1. See, 5 is greater than 3. So 5 is the maximum column value. And from B2, we are getting 4. And from this column maximums, we are having the minimum value. So 4 is less than 5. So 4 is the minimum. So maximum, see, it is given right in the next slide. Maximum is 3, minimax is 4, which is not equal to each other. So that means in this type of cases, in this example, we can see there is no saddle point. So this type of cases will be there where there will be not a single saddle point. Next, games where more than one saddle point or multiple saddle points. If you check, there are again two players, player 1 and player 2. Player 1 is having 4 strategies A, B, C, D. Player 2 is having also 4 strategies. Now you can see if you go to A, B, that means player 1 is taking A and player B is taking B. That means 2. Similarly, we are having from C and C, that means player 1 and 2 both are choosing option C. That is also 2. So we can say 2 is the saddle point, one saddle point. Similarly, if you check again AC, that means if player 1 is choosing A and player 1 is choosing A and player 2 is choosing C, that is also 2. Okay, and if they choose CB, that is also 2. So there are more than one saddle points in this example. So just like this one, there can be such games where there are multiple saddle points. Next, now I am focusing on the main topic what I have started with, that is prisoner's dilemma. So it is a very interesting thing, very, very interesting thing. What is happening over here? Let me tell you. In this case, the prisoner's dilemma gives a paradoxical analysis in game theory. What is happening in which if two players act in their own interest, optimal solution cannot be derived. That means if two players are thinking about their own self only, if they are thinking about their selves only, optimal solution cannot be derived. A typical dilemma of prisoners is formed in a way that both the player chooses to save themselves at the cost of the other player. That means they both should, you know, help each other. Okay. So as a result, they find themselves in a war state. If they had chosen to cooperate each other in the decision making, then they could be able to achieve the optimal state. That means, as a result, means which kind of result it is? If they do not cooperate with each other, if they are being selfish, if they are choosing that particular decision, that particular strategy where they are only thinking about their own interest, they will be losing. Okay, they will be in a war state. So to get optimum state, what they need to do? They need to cooperate each other in the decision making process. How? See, this is a very, very important example of prisoner's dilemma. And while explaining prisoner's dilemma, you need to write this one. Okay. So this dilemma represents a situation. This dilemma, one second. Yes. This dilemma represents a situation in which the two players in the game have been suspect of a crime and have been arrested and placed to interrogate in separate rooms. That means they are unable to communicate with each other. So they are placed into separate rooms and the interrogation is started and they cannot communicate with each other. So there are no other witnesses. So only option to prove their crimes is their confession. That means if they confess, only the case can be proved. If at least one of them confess, the case can be proved. Okay. Accordingly, each of them is being faced with the choice to remain silent or cooperate and confess. That means they are having two choices: to either to remain silent, okay, or to confess the crime. Okay. So here, each of them has two possible strategies or outcomes. There are 4 possible outcomes in the game. As each of them are having 2 possible outcomes, there are total 4 possible outcomes in the game. Now I'm telling you the first one. If both the players confess, what will happen? Each of them will be having a fewer punishment. That means a less amount of punishments. They will have to be in jail for 5 years. Both of them will be in jail for 5 years if both the players are confessing. Okay. Or in the next one, if one of them got betrayed by other, that means one of them confesses and another one remains silent. What will happen? Then the silent one will be punished strictly with 20 years of jail. That means the silent one have to be in jail for 20 years, whereas the player who confessed gets go free. Okay, that means that particular person who is confessing will not have to be in jail. Okay, she or he gets go free. So next one, if both of them cooperate and remain silent, what will happen? Then the authority will only be able to jailbird them on a minor charge. Okay, that means the punishment for both will be to be in jail for only 1 year. Okay, which is a very less amount of punishment they're getting. So in this strategy, this is the Nash equilibrium where they can reach the optimum optimum value, or you can say optimum strategy, where they both are cooperating each other by remaining silent and not confessing the crime. See, in this diagram, or you can say table, payoff matrix, whatever it is, we can see there is prisoner A and prisoner B over there. We are showing the prisoner B strategy in the columns and prisoner A strategies in the row. See, for prisoner A and B, if both of them confesses in the first cell, leftward side corner, upward, the upper left corner first cell is showing 5 years of jails for both. That means when they both confess, they will be having 5 years of jail as a punishment. Okay. If prisoner B remains silent and A confesses, what will happen? A will go free and B will be in jail for 20 years, which is a huge time. Similarly, if you go to the left downward cell, that means prisoner A is not confessing, remaining silent, and prisoner B is confessing. What is happening? Prisoner B gets go free, but prisoner A, who remains silent, will be in jail for 20 years. But our Nash equilibrium, that is, if both of them cooperate each other by not confessing their crimes, remaining silent, what is happening? See, both of them are in jail for only 1 year. Okay, they are having the punishment of only 1 year jail. So this is the Nash equilibrium. Both are cooperating each other and having the optimum strategy. See, Nash equilibrium, on a brief, I can say it is the situation where the optimal outcome of a game can be achieved. Here, players have no motive to diverge from the preferred strategy. See, from that particular Nash equilibrium strategy, that is, both are remaining silent by getting punishment of 1 year jail. They will not move from this strategy. This is a very stable strategy, because if they move on, one of them can be in jail for 20 years, and even if both of them confess, they have to be in jail in 5 years. So which one is better? 5 years jail of each? You have 1 year jail of each. So that's why in that case here players have no motive to diverge from the paper strategy, because there is no benefit from altering the actions, keeping the other player strategies constant. Here in the above example of prisoner's dilemma, the Nash equilibrium is -1, which means the situation where both the prisoners remain silent by cooperating each other. That means without confessing the crime and getting a punishment of only 1 year of jail. So it is that's it about prisoner's dilemma. I have done with my topic today. So I'm just stop sharing the slides. Thank you so much.